Hello. Can you? Oh, sorry. I'm not actually a cat. Let me switch this. Hello, Arshia. Can you see me now?
Yes, Tony. But now I think you're muted.
Ah, thanks for letting me know. Okay. This is a presentation of our work along with Professor Haojian at UCSD. Redesigning privacy with user feedback, the case of Zoom attendee attention tracking. In the tech industry, software engineers often overlook potential human and social implications of their product designs, especially user privacy, in favor of rapid execution. This sentiment has often been described and criticized in terms of Facebook's internal motto prior to 2014, move fast and break things. However, after releasing a new product feature, these companies sometimes face significant backlash from the users and decide to roll back the feature, not only squandering substantial resources, but also damaging their reputations. One recent example is the attendee attention tracking feature in Zoom, which received significant criticism after launch. The Zoom team later apologized and removed this feature.
Zoom's attendee attention tracking feature allowed the host to monitor the attendee's attention if Zoom was not the application in focus on a participant's computer for over 30 seconds while someone else was sharing their screen. Zoom showed a timer icon next to the participant's name in the participant panel. At the end of each meeting, Zoom also generated a report listing the percentage of time each participant was paying attention.
One important cause for product setbacks like Zoom's is failing to integrate user feedback in the early stages of product design. Earlier research has explored various techniques for gathering user input on privacy aspects of different product designs. However, a relatively under-investigated question that we looked at was how end developers might effectively leverage actual user feedback to enhance the privacy of end-user products.
In order to explore this, we began with formative pilot interviews to understand how software engineers might reflect on a real-world data practice to improve its privacy. We recruited 5 software engineers through personal networks for exploratory semi-structured interviews, using Zoom attendee attention tracking as an example to focus design ideas.
This pilot study revealed a couple common participant behaviors. First, participants' ideas mainly focused on very similar user concerns that they would anticipate as attendees. Second, participants' ideas were generally high level and lacked engineering actionability. For instance, nearly all participants focused their ideas around enabling multitasking while being tracked as an attendee, but there was much less consensus on if there were any engineering solutions for this. You may refer to our full paper for more details on these interviews.
Based on this study's preliminary findings, we observed that participants could benefit from more guidance, potentially in the form of more diverse user perspectives, to devise more effective and coherent privacy-aware design solutions. We also found that participants were able to ideate on a specific feature, both as an end user and as a software developer. Thus, we used this pilot study to formulate the methods for our main study, deciding on real user feedback as a way to ground participants' ideas towards more actionable solutions.
To collect this real user feedback, we surveyed social media platforms and online publications, including Reddit and Hacker News, and filtered down to 61 historical user comments referencing posts and threads about Zoom's attendee attention tracking. We conducted qualitative open coding and agreed on 3 high-level categories for these comments, which align with existing work on ethical principles: respect for persons, beneficence, and justice.
We then conducted semi-structured interviews with 18 software engineers to redesign Zoom's attendee attention tracking feature, iteratively presenting 3 to 4 user comments from each category and asking participants how they might adjust their designs based on the feedback. To analyze the interviews, we independently conducted inductive thematic analyses to categorize design suggestions and explore participants' rationale for those decisions. As a part of those interviews, we also encourage participants to sketch out their design ideas. Here is an example of one of one participant's sketches, designing a disclaimer message and a notification bar in the UI, as well as outlining a potential data handling procedure.
In terms of participant demographics, most participants worked in larger companies, and most were based out of the United States. 3 out of the 18 participants identified as female, and the rest identified as male. In addition, most participants did not have any experience with privacy frameworks, but came from a range of years of experience working as software engineers. The results of this study suggested that integrating user feedback into software development for privacy can be beneficial, but also has its challenges. Potential benefits included the ability to use feedback as checklists for edge cases, providing a way to cross-check anticipated user concerns, and as evidence to inform higher-level organizational privacy decisions, such as enabling a product change they wouldn't normally be able to make on their own.
One challenge we noticed was that the raw user privacy feedback sometimes resulted in polarized design solutions, either focused around specific interface changes which would not easily scale across different types of user concerns, deprecation of the feature. In terms of front-end changes, transparency in the interface describing how data was used was a common design suggestion. You can refer to our full paper for more details on these design suggestions.
Another challenge was confirmation bias, where user feedback, which aligned with participants' expectations for user concerns, boosted their confidence in designing changes to address those concerns. But feedback which did not align with expectations tended to be deferred to other decision makers or simply ignored.
A third challenge we observed was with the participants' perceived responsibility in designing for privacy. Participants generally considered privacy decisions to be higher level product changes outside their primary engineering role or otherwise dependent on outside factors such as legal regulation. Non-engineering organizational partners were usually trusted to determine the perceived balance between feature prioritization and user privacy comfort.
Some potential ways to address these challenges include a more standardized format for presenting user feedback to developers, fostering more developer empathy with users, and exploring feedback as a way to inform product decisions. Another research direction could also account for different types of user feedback, such as positive feedback, which was out of scope for this work. Future work would rely on a strong collaboration between HCI and software engineering research communities, especially to find if these findings could scale to a wider privacy framework or guideline for practical use in industry. In summary, for this work, we used Zoom attendee attention tracking as a lens to explore the process of integrating user privacy feedback into software development. Our results suggest the benefits of integrating user feedback into software engineering for privacy, but there is still work to be done to address the challenges that we found.
Please refer to our paper for more details on this work.
Great. Looks like we finished a little early, so we can go ahead and end this meeting and give you all back a few minutes. Feel free to follow up with us offline if you'd like to hear more about this work. Thank you, everyone.
Did you remember to stop the recording?
Oh, where do I just click this button? Yes.